Hey guys, Stephen Fleet here again. Some of the earlier videos I posted, I talked about where I developed an equation 3x plus z, where z alternates between +1 and +2. Ended up being basically just rediscovering one of the Dirichlet series, with just a slightly different twist. So I've been playing a little bit more with this equation. In this case, I chose to add 1. My thoughts as I'm working through the Riemann hypothesis, what we know with the Euler equation related to the zeta function is that Euler used the zeta function and they multiplied by the second term in each of the series, and he subtracted one from the other. And that's essentially what I did with this equation. I added the 1 in there to start with, just so I could get it to work. And I did it to where I multiplied by 5, subtracted 1 from 2, the first equation for the second equation. Same thing, then multiplied by 7, subtracted third equation from the fourth equation, and so on. And as I kept building it out, essentially developed an equation like this, which is kind of similar to the Euler equation, and it would equal to the sum of the primes. Then I noticed, hey, once you expand this, it's essentially a quadratic equation. So as I kept digging deeper, what we know with quadratic equations, the vertex is negative b over 2 alpha. In our case, it doesn't matter if you start with 1 or if you start with 5, what you're going to have is negative b over 2 alpha, which if you start with 1 is negative 1 over negative 2, so 1/2. And if it was 5, say your first prime value would be negative 5 over negative 10, which would still be 1/2. So you're always going to have 1/2. So I'm being very cautious here, but it makes me wonder if maybe all of your non-trivial zeros are on the critical line of 1/2 because of this, because in essence you put it into a quadratic form, to where your x value of your vertex is always going to be 1/2. Now, actually, the y values, when you actually do the equation, you get 1/2. Let me get the focus here. There we go. You get 1/2, and then plus a value or minus a value that's imaginary. So I still got some work to do here to see if it equals the non-trivial zeros. But hey, take a look at it yourself. I'm sure there's more to it here. I just got to build it out a little bit more. Thanks.